So in this video we will be going through the recap of earlier problem. Design a lap joint between two plates each of width 120 mm if the thickness are 16 mm each. The joints has to transfer factor load of 240 kN. The plates are of Fe410 grade. Use M20 bolts of grade 4.6 bearing type. In this case, solution consists of the step number 1, diameter of bolt, then diameter of a hole, ultimate strength of the plate, bolt, and then minimum wedge distance and minimum pitch distance. Now we will be going through the step number 2 where the strength calculations are there. Design shear strength of one bolt in single shear. So this is as per clause 10.3.3 page number 75. So if we just look at now clause number 10.3.3, that is shear capacity of bolt. So the design strength of the bolt VDSB as governed shear strength is given by VDSB equals to VNSB divided by gamma MB, where VNSB is equal to nominal shear capacity of a bolt, which is calculated as follows. So we need to use here properly all the symbols, and if we just look at the symbol here, VNSB, this is actually nominal shear capacity of a bolt, and we need to calculate as this formula is given. VNSB equals to Fu by root 3 into NN into ANB plus NS into ASB. So there are different parameters, and these parameters are explained as below here, where Fu is the ultimate tensile strength of a bolt, then Nn is the number of shear planes with threads intercepting the shear plane. In our case that would be equals to 1. Ns is the number of shear plane without thread intercepting the shear plane, and then ASB is nominal plane shank area of the bolt, and in our case we are not Ns is equal to 0, and that whole will be equals to 0. And similarly ANB is equal to net shear area of the bolt at the thread may be taken as the area corresponding to the root diameter at the thread. Okay, so there are all the parameters explained as per IS 800 2007. Now what we need to do is to go ahead with the calculation part. So here VDSB is equal to VNSB, and that divided by gamma MB. And we will put up the formula of VNSB, that is Fu B by root 3 into NN into ANB plus NS into ASB into 1 by gamma MB. So Nn is equal to 1 because we have only two plates, and that is the reason there will be only one shear plane. Ns without thread we are not going to consider. With thread that is the bolt, and therefore that parameter Ns equals to Ns into ASB, that would be equals to 0. Now we will calculate A and B, that is the area of the bolt, and we need to consider the area of the bolt. Now this is 78% of the area. Why? Because there will be certain threads. So 0.78 into pi by 4 into 20, it is the diameter of the bolt, nominal diameter of the bolt, and if you calculate, that would be 245.04 mm square. Now therefore VDSB we will calculate, and that is equals to FUB, that is 400 divided by root 3 into 1 into 245.04, and 1 divided by gamma MB. Now this gamma MB, it is the partial safety factor, again from IS 800 2007, table number 5, page number 30. So this is table number 5, page number 30, and we can check this is the particularly partial safety factor. We got it. And that is equals to gamma MB equals to 1.25. So we'll put the values, and then if you just solve, you will get VDSB is equal to 45.27 kilonewton we can write down that gamma MB is from table number 5, page number 30 of IS 800 2007. So this is how the design shear strength of the one bolt in single shear, that is from clause 10.3.3, can be calculated. VDSB, that is 45.27 kilonewton we got. And the next part would be design bearing strength of one bolt So again, that is from the clause number 10.3.4, page number 75. So now if you just look at here, that is the IS code clause 10.3.4, bearing capacity of the bolt, and that is the design bearing strength of a bolt on any plate as governed by the bearing, and that is given by here this formula. VDPB equals to VNPB by gamma MB. Here VNPB is nominal bearing strength of a bolt, which is given by 2.5 kb into D into T by Fu, D into T into Fu. So this is how you will get VNPB. Now where kb is the smaller of this four parameter, e by 3d0, p by 3d0 minus 0.25, fu, b by fu, and 1. Out of all the four, whatever the value is coming out to be, whichever is smaller, that is to be considered as kb, value of kb. Now here E and P, it is given as end and pitch distance of the fastener along bearing direction. Then D0 is diameter of the hole. Then FUB and FU, that is ultimate tensile stress of the bolt and the ultimate tensile strength of the plate, stress of the plate respectively. D is the nominal diameter of the bolt, and T is the summation of the thickness of the connected plate experiencing the bearing stress in the same direction. So as per you can say, T is the thickness of the connected plate. So if we just look at this formula, we need to put it all the parameters, and once we put all the parameters, in that case we can solve. For the design bearing strength of one bolt. So now if we just write down here, VDPB equals to V and PB divided by gamma MB. And that is equals to, if we just put up the formula of V and PB, that is 2.5 kb into D into T into FU divided by gamma MB. 2.5 kb into D into T into FU, and that is divided by gamma MB. Now just put up the value of kb. Kb actually it is the smaller of some of the parameters. There are the four parameters. Out of that, the first parameter is E divided by 3 times D0. E we already calculated, that is 38 mm. And that divided by 3 into D0. D0, you know, that also we have calculated, 22 mm. Now once we put up all the values, we will get by solving this thing, and we'll get around 0.58. So that's the first parameter. Now the next parameter is, that is the second parameter, P divided by 3D0 minus 0.25. So P we already calculated, 50 mm. So 50 divided by 3 into 22 minus 0.25. So here we get 0.51. So that is the second parameter. Now if we go to the third parameter, so what is the third parameter here? So the third parameter is FUB divided by FU. So FUB divided by FU, if we just solve, 400 by 410, and that is equals to 0.975. And the fourth parameter is 1.0. So out of all the four parameters, we do have the smaller value, and that is the second parameter. And what we get is equals to 0.51. Yes, that's it. That is the value of kb. So we got the value of kb here. Now we need to put it into the further equation. and therefore VDPB equals to 1 by 1.25 into 2.5. Just we'll refer the formula. Yes, that's it. 2.5 into KB, we have just find out 0.51 into D. The value of D is 20, then thickness, that is T, equals to 16, and then FU for the bolt, that is 400 divided by gamma MB, which we already written there, 1.25, and if we just calculate it, all the things, all the parameters here, so we will get it around 133.824 kilonewton. So this is how we calculate VDSB. We have calculated earlier in 45.27, and now VDPB we have calculated 133.824 kilonewton. So these are all the two terms which we have calculated in this step number 2, and out of these two, whatever is the maximum value that is to be considered for the further calculation. What is the maximum value here? VDPB 133.824 kilonewton. So the first case we got VDSB, and the second case we got VDPB. So now the next one is actually maximum one, that is called as bolt value, and that is equals to 133.824 kilonewton. So maximum out of these two, we got it here, bolt value, and therefore now we can calculate number of bolts required, and that is equals to load divided by bolt value. Load is to be taken from the problem, and in the problem load is already given, that is of 240 kilonewton. So you can write down there 240 kilonewton. That is 240 divided by bolt value 133.824. If you just solve and make it round up, you will get two numbers. So this is what all about this step number 2, where we have calculated different two strength of one bolt by referring to IS 800 2007. So in the next third video we will be going through the next step. Thank you so much. This is Dr. Shrikant Harle, and I'll be guiding you all about the problems related to the steel structure. Specifically, we are going through the connection part here. Okay, so thank you.